About stars. So, what are the factors? What factors contribute to a star's brightness? Well, the distance contributes to the star's brightness because if it's farther away, it looks a lot dimmer. Like, here's an example. If it's farther away, this looks dimmer than like this. If that's right next to me, it's going to be bright. But if it's not next to me, it's not going to be as bright. So, like, that's kind of like a star. If it's closer to you, then it's going to be brighter. The temperature also has something to do with how bright it is, because if it's hotter, if it's a lot hotter, it could be a bunch brighter, and you could see it better. The size also contributes to a star's brightness because if if you the size contributes to stars brightness by like the size. If the size is if something is really big and it's right next to you, it's probably going to be really bright. But if it's smaller, it's probably not going to let off as much light. So that has also something to do with the star's brightness. Look, the Betelgeuse is the biggest star in the solar system. Like, these are the main sequence stars, and if you could see, this right here is the sun. It's a main sequence star, and it's not just yellow. It's like yellowy white. So it's not like it's around 10,000 years. I mean, not 10,000 years, 10,000 degrees Celsius. The blue stars are colder, and the whiter, the lighter. No, so let me say that over again. These ones are a lot hotter. I'm sorry. The dark blue are so much hotter than these. These are 30,000 degrees Celsius, and this is 3,000 degrees Celsius. The biggest star in the solar system, Betelgeuse, I don't know if he's in your solar system, is Betelgeuse, I'm pretty sure he is only like 3,000 degrees Celsius, and he's the biggest one. And these guys, he's so hot, but look at how tiny he is. This is the star that you can see the most, like it's the brightest star in our night sky. And what was I going to say? I don't remember what I was going to say. Oh, pretty sure it was this one, Spica or something. I don't know how to pronounce it. Is the star you can see the most blue in the solar system. So it's the star that appears the most. It's blue. So yeah, and I know I already showed this, but like if it was closer to you and it was fire, it was gonna be so bright. But if it's far, it's not going to be as bright as it was if it was near. Like, so this one shows spectral class. Oh, a bluish color and above 31,000 degrees. So, like, this would be the color it is and how hot it is. It's like 5,950 degrees to 7,100 degrees, and like it's yellowish white. But the bluish one is like above 31,000 degrees. The spectral class is like, so that would be called like an O star or a B star or an A star or an F star or a G star or a K star or an N star. And then stars' brightness is determined by size. The larger of two stars, let's say that over. The larger of two stars with the same temperature at the same distance is bright.
This is talking about
Okay, now I understand. The larger of the two stars with the same temperature, the same distance is brighter. Because if it's larger, it's gonna be brighter than if it's tinier. Like if it's like as big as like if it's as big as a bouncy ball, like a glow in the dark bouncy ball, and a glow in the dark tennis ball, it's probably the tennis ball's probably gonna be brighter because it's probably gonna let off more light since it's so much bigger than it. But if it's farther away, then it might not be as like as bright because it's gonna be dimmer, and then the smaller one will look like bright. I mean, like they would be the same because of how far away the other one is. So now I'm gonna answer some questions for you. Okay. Create. LeBron and Trina are talking about the sun and other stars. Trina argues that the sun is much larger than the other stars in the sky. She also explains that most of the other stars are about the same size. Trina argues that the sun is much larger than all the other stars in the sky. She also explains that most of the other stars are about the same size as each other and the same distance from Earth. LeBron disagrees. He explains that the sun looks larger than the other stars because it is closer. He also argues that the other stars vary a great deal in size and distance from Earth. Who is correct? Explain your answer. LeBron is correct because the sun is super close to us. Like 8 light minutes away. But the thing is, that the other stars in the sky appear to be smaller, and like Betelgeuse is so much bigger than the sun, but it just appears to be tiny, like tinier, way tinier than the sun. But it actually isn't because it's just far away, so it looks like it's so tiny. Like if you threw a bouncy ball all the way down the hall, and then you threw if you threw a tennis ball all the way down the hall, it would look tiny. But if you left the bouncy ball right here, it would look so much bigger than the tennis ball all the way down the hall because of how I lost my words. Oh my gosh. Because of the distance. So he's correct because the tennis ball would look so much smaller than the bouncy ball. If the bouncy ball was sitting right next to me, it would look like bigger than the tennis ball all the way down the hall. So yeah. Thank you for watching.